So radiant barrier is a product that we use to reduce heat flow. Basically, there's several different types of radiant barrier out there. There is the spray on or paint on type that comes in a can. There's the decking that a lot of the new homes are coming with, or if you want to replace your roof and replace your decking, tech shield or whatever you call it. There's several different manufacturers that has sort of a laminated foil piece to the decking, and then there's the foil itself. So we've always installed since day one the product that really works, and the foil that we use. We also have a copper film or sheet that's stapled up to the rafter underneath the roof. The reason that it's more effective than the other two stated is it has some space to breathe, right? So our radiant barrier is stapled up with air compressors and staple guns and the right air pressure and the right length of staple and so on and so forth. Is stapled up below the rafter so you have some separation between the material and the roof deck. And when you have that separation, there's no risk of increasing roof temperature or voiding shingle warranty or mold or mildew or delamination or any of the many things that can happen when you put something right up against the roof. So a radiant barrier is a heat reducer. You've got heat coming through the roof all day long, and the attic is heating up and heating up and heating up. And so the same idea is putting the visor in your windshield, metal fold out, pop out deal when you go into the store or whatever. When you come back out to your car, the car is still hot, absolutely, but it's not as hot as it would have been without that protection. And so the car cools down a little bit quicker when the AC kicks on, and you get down the road a little more comfortable faster. So same idea with the attic. The reason the attic temperature is important is because typically here in Texas or in North America, your air conditioning equipment and or your ductwork is in the attic, right? So when your attic's 150 degrees, you're counting on a mechanical system to produce cold air to your house in that environment. And so radiant barrier at the source, at the roof line, not on the floor, can reflect and keep that heat and slow down that heat transfer and slow down that process where the attic is getting so hot and cooking your system. Typically we see 20 to 40 degrees, and so if it's 100 degrees outside, radiant barriers foil with that separation can give you 30 to 40 degrees of relief. We've seen it summer after summer. If it's 80 or 90 outside, it will get it really close to outside temperature. So your attic does not have to be 70. It does not have to be room temperature. Your equipment can operate in a 100-degree attic. It just can't operate efficiently in 140.